Good morning. I'm Rainier Sander Ramos, and this will be the report of my progress for this project, Making Ends Meet, Forecasting Urban Population Extremes via Geographic and Temporal Weight Regression Model. The objectives of this project is to first predict the population distribution density or in the Philippines given the temporal data from 2016 to 2020, and we aim to identify spatial correlation between Philippine urban areas using a Voronoi tessellation algorithm, and analyze temporal correlation of urbanization using the change in population density for each of these generated Voronoi regions. Finally, we want to forecast population extremes for the succeeding years using regression models or polynomial fitting of the linear combination of these correlations. Some related works that was previously done is from Wang et al., published in 2022. Here they project, their work is entitled Projecting 1 Kilometer Grid Population Distributions from 2020 to 2100 globally under shared socioeconomic pathways. So here they used random forest algorithm based on 2015 World Pop data to sample points from each region to build spatial dependence. This is shown in the top left figure. And below is the distribution of the sample points for each region generated by this RF algorithm. And the results is shown in the middle figure, the one with blue columns. So here they show 5 scenarios, 5 shared socioeconomic pathway scenarios from the 2020 data. So they predicted population density or population changes for each region, specifically here for Paris, France, using 5 pathway scenarios: the sustainability, middle of the road, regional rivalry, inequality, and fossil fuel development. Okay, and the rightmost figure is a screenshot from the traffic map from Google Maps yesterday. So that was Sunday, October 20, right? So we can clearly see that in the future, in 2100, there might be some predicted high population density in Paris. Okay. Another study by Hilario et al. Entitled Forecasting Urban Population Distribution of Iloilo City using GIS and spatial autocorrelation models, which was published in 2021. Here they use the annual population growth map dataset from 2010 to 2020, as shown in the top left figure, or in the leftmost figure. So they used Moran's I statistic and LISA for detecting spatial clustering between the barangays in Iloilo City. And if there exists a spatial dependence, then a regression model via ordinary least squares or Lagrange multiplier algorithms is used to forecast the population, as shown in the right figure. Okay, so here they have the actual population in Iloilo City data from 2020 and the projected population city. So there are just a very few barangays within, I believe that was within 5% error for their projection. Okay, so for my current progress, I already extracted dataset from World Pop 2020 to 2016 to 2020. So this is a raster plot of the 1 kilometer radius population distribution of the whole Philippines. And now I was able to test some Voronoi tessellation by randomly sampling points within the map of the Philippines, and then generating the Voronoi regions and studying their zonal statistics for each of these Voronoi region generated. So why are we not using administrative boundaries such as provinces? This is because some administrative boundaries may not imply some spatial dependence exactly, but just some political administrative functions, right? So this is already included in one of the motivation of the first study that I presented earlier. So my to-do list is to use random points in polygons method, because here I just manually sample the points, but we can use a function from GIS itself using random points in polygons, and from there we can create or provide a tessellation of a Voronoi tessellation for the whole region of for the whole map of the Philippines, and again apply zonal statistics and regression models afterwards. So I aim to create a network with random points as the spatial nodes for spatial dependence, and then the temporal dependence will be the data sets from 2016 to 2020 actually. And from there we can now predict or forecast population extremes. So that's all for this progress report. Thank you.